All right, so today we're going to look at inverse relations to begin with. And this is similar to functions that you talked about in algebra. So, how do you get an inverse relation? Well, the answer is given a relation r from x to y, the inverse relation is just all the ordered pairs flipped. So, the way I can write that is r inverse is the set of ordered pairs y comma x such that x comma y is in R. So how do you get an inverse relation? The answer is you just change the order of the ordered pairs. So in particular, let's look at an example that we've used before, R9, which is a relation on the set ABC, is AA, BB, CC, and AB. So what is R9 inverse? Well, I take the ordered pair AA and flip it. That just gives me AA. BB, I flip it. That just gives me BB. CC, I flip it. That just gives me CC. And here's where it's different. If I have AB, then I have BA in the inverse. Okay, another example might be R10. Again, if I want R10 inverse, I just take all the ordered pairs and flip them. It doesn't change these two, but AB gets flipped to BA, and BA gets flipped to AB. And if you'll notice, R10 is the same as R10 inverse. So in fact, they're the same relation. When is that going to be true? When is a relation equal to its inverse? Well, I claim if you think about it, a relation is equal to its own inverse precisely when R is symmetric. Because remember, the definition of symmetric says anytime I have an xy in R, I also have a yx. All right, so that's got inverse relations. Now I want to talk about relation composition. So let R1 be a function from x to y, and R2 a relation, we're talking relations here, a relation from y to z, then I claim that you have a natural relation going from x and starting at x and ending at z. And we denote that R2 composed with R1. So what's R2 composed with R1? It's the set of ordered pairs x, z such that I can find something in y where x comma y is in R1 and y comma z is in R2. I'm going to draw a diagram to show what's going on. R1 is going from x to y. R2 is going from y to z. And the composition, R2 composed with R1, starts at x and ends at z. You looked at compositions of functions back in algebra, and you should recall that f circle g of x means what? F of g of x. By the same token, g circle f of x means g of f of x. And so if you think about this, let's give a particular example. Suppose f of x is x squared plus 2, g of x is x minus 4. Then what do I mean by f circle g of x? The answer is it is f of g of x, or f of, what was g? X minus 4, or x minus 4 squared add 2. And when you clean things up, I think you get x squared minus 8x plus 18. Notice g circle f of x is g of f of x, which is g of x squared plus 2. And plugging x squared plus 2 into g gives me x squared plus 2 minus 4, or x squared minus 2. Notice g circle f of x is not the same as f circle g of x. You get two different things. And in general, that's true. Function composition, it matters which order you do things in. The other thing I want you to notice is, if I'm talking f circle g, what is the first function that you plug into? The answer is g. Now that's a little different for those of us in the West that have a tendency to read from left to right. To remember that f circle g, the first function is g. All right, so now let's look at a particular example where I have a relation going from x, ABC, to y, 1, 2, 3, and we just make up a particular relation. Suppose it's R1, which looks like B3, A2, and A3. Certainly that goes from x to y. Now think about the relation R2, which we just named some ordered pairs. Z is going to be my set alpha, beta, gamma, delta. And let's let R2 take 1 to alpha, 2 to gamma, and 3 to gamma. All right, so now the question is, what is my composition R2 composed with R1? Well, I'm drawing what's called an arrow diagram. To represent these relations. So R1 goes from x to y. I represent those by arrows. A goes to 2. And also A goes to 3. Look at those ordered pairs up there. And B goes to 3. That's R1. Now what's R2? It goes from Y to Z. So R2, we chose to send 1 to alpha, 2 to gamma, and 3 to gamma. So 1 goes to alpha, 2 goes to gamma, and 3 goes to gamma. So what is the composition R2 composed with R1? Well, it's anytime I can start over here and I get all the way over here, I put that ordered pair in my composition. So see, A goes to 2, which then goes to gamma. That says I have the ordered pair A comma gamma. A also goes to 3, but that goes back to gamma. I already have that ordered pair, A comma gamma. Finally, B goes to 3, which then goes to gamma. That gives me the ordered pair B comma gamma in my relation composition. All right, so that's how relation composition works. And I'm going to stop there.